Hello, everybody. This is the last lecture before exam 3, and this is for two-factor ANOVAs. And so essentially just all the ANOVA stuff will be on exam 3. There is a study guide that's posted already, and I will try to make an audio review or a review of that. And so we've already done one-way ANOVA, which is one IV or PV with 3 or more levels against a dependent variable that is at least interval level. So something that has numbers that we can do numeric mathematical operations on. And then we have repeated measures, ANOVA. And so that in that case, we also have one IV or PV. Again, it's we're treating it as categorical. So even if it is a interval or ratio, we're actually putting it in categories. And there's 3 or more levels, 3 or more categories there. And it's within subjects. And so it's each person gets all levels of the IV or PV. It's probably not a PV. PV is really difficult to do within levels, except we do have cases where we have the sleep thing, for example. So if you measure people at 3 different times, that would be within subject's design. So if you look at your sleep now, and your sleep 1 month from now, and your sleep 2 months from now, and compare those 3 numbers, that's within subject's design. So it can be a PV. Or it could be like IV with, let's say, red, green, blue. So for every single person, I'm going to show you somebody in red, rate their attraction. I'm going to show you somebody in blue, rate their attraction. I'm going to show you somebody in green, rate their attraction. So that's repeated measures. It's within subjects. The one-way ANOVA is with between subjects, and you only get one level of the IV. So if you are doing the color study, you would only see either red or blue or green. You wouldn't see more than one of the colors. So those are what we've covered so far. Now we're going to cover two-factor analysis of variance. And so let's talk about what that is. So this is a more complex type of analysis. And so basically, when we talk about two-factor ANOVA, it means that a factor is a variable. So now we're talking about 2 independent variables and or predictor variables. So they each count as 1. So you could have one independent variable and one predictor variable, which here the book calls it quasi-independent. So that's a predictor variable in our book. So it could be one IV and one PV, or it could be 2 IVs, or it could be 2 PVs. So you have 2 things, whether it's an IV or a PV, 2 things that you're using to predict the dependent variable. And basically, the whole rationale behind that is we actually are curious about probably what we call interactions. So a big thing that you're going to get out of this lecture is a thing called interactions. And so let's say that we have 2 variables, and we've talked about this before in terms of just labeling PVs, IVs, and DVs and level of measurement. So on an exam, we had an IV, which is the color. So let's make it a true ANOVA type of variable and have 3 levels. So let's say that we show people either red, green, or blue clothes on people and have them rate their attraction. So there's 3 levels of that variable, and it's an independent variable. And then we talked about sociosexuality as a predictor variable. So how much does somebody think about sex? Maybe they're going to respond to the colors differently depending on that level. And so it is an interval level measurement, but we could make it into categorical for the purpose of this ANOVA. So we can have people who are high medium, and low. So we can break people up into 3 different groups. People who think about sex a lot, they're high on that variable. People who are low on that variable, they don't think about sex much. At least they don't admit to doing it. And then there's medium, so people who are in the middle. So now we have a predictor variable. So we have one IV and we have one PV. And we are going to do a two-factor ANOVA. And basically what we do with this is that we do exactly what we did before with both of these things are between subjects, the way that we talked about just now. So one level for each person. So we would essentially do a one-way ANOVA for the color. We'd run that and we would see if color affected attraction. And if color, that test of whether color affects attraction, we actually call that a main effect. So a main effect is just simply, and it's MAIN. A main effect is simply, does one of those variables in your study affects the DV? So in this case, does this IV of color affect the dependent variable? So we call that main effect. So we would test that main effect essentially with a one-way ANOVA analysis. So we'd see if there's a main effect, if color has an effect on attraction. Then we would do a test of the other main effect, MAIN, is whether the sociosexuality, how much somebody thinks about sex, affects people's attraction. So we would do basically another one-way ANOVA analysis of the variable of sociosexuality, and we'd see if that variable by itself affects attraction ratings. That's another test of main effects. So we have 2 tests of main effects. In this case, we have color main effect, and we would test it, so we don't know. We're just going to test that effect, yes or no. And then the sociosexuality, yes or no, does it have an impact on the DV? And then the big thing why we actually want to do this type of study or design is we want to see if there's an interaction. So the interaction is simply asking, does somebody's reaction to those colors depend on their level of sociosexuality? And so we could make a hypothesis. We could make a hypothesis that people who are sociosexual and think about sex a lot might be more sensitive to the color red, because the whole argument behind this research that at least suggests that red is a enhancer of attraction, and it is. Their argument about why it works is some sort of evolutionary argument that red is a sexual signal. And so based on that, we could say that we think that, yes, most people will respond to red and increase their attraction, but that increase in attraction for the red color is going to be greater for the people who are high on sociosexuality. So that's what an interaction is. And I didn't plan to do this. I'm just sort of going off this because I'm looking at these slides and I think they're a little bit difficult. As I'm doing this, I'm going to give you some relief right away, is that we are going to do no computations for this topic. So one big reason for that is if we were to do that on the interactions we're going to talk about, it would take you a very long time to actually write this stuff out. And so, and also you can imagine if you had to do 2 one-way ANOVAs plus an interaction, which is actually a longer calculation, it'd take you like 5 hours, 6 hours to do one problem. So we are not going to do computations for this topic of two-factor ANOVAs. We are also not going to have homework on two-factors ANOVAs. And I'd have to check on the labs. So I will make a check on the labs, and I'll make an announcement about that, and it will be on Canvas. I'm going to say I'm 90% sure we aren't going to have a lab on the two-factor because it's a bit too complex, I think. And it actually takes some interpretation, and we're actually going to do a non-graded exercise in this lecture that gets to the same point. And so I think I'm 90% sure we're not going to have a lab. It will show up on Canvas if we do, but I'm fairly sure of this. And so we were just talking about red and whether people who are high on social sexuality would be more sensitive to that. And so if we were going to do an interaction on this, we would actually have to draw it out. And remember, I'm using this very small mouse pad, so it's not going to be a great drawing in any sense of the word because I have to use this little pad. And so remember, on the vertical, we always put our dv. So this is attraction. So this is attraction. Again, we always want to put our dv over here. And then the way we do interactions is we can think about, oh, how are we going to sort of show this? And I think I'm going to show this with lines because I'm going to have you do lines for examples, but actually it shows probably a much more complex thing here because it's ANOVAs, and we talked about 3 levels here. But I'm going to do lines anyway because I think it's easier. So actually we can't do lines. We have to actually do bars. I'm going to do blue here, green, and then red. And so we're going to have bars, and this bar will be low on social sexuality. This bar will be medium. Not medium. And this bar, where we're basically shading it in, is high. So somebody who's low on social sexuality, their attraction rating for blue, we don't think blue is going to be a real enhancer anyway, so it might be like that. Green is probably not much of an enhancer either. And then maybe they might get a little bit of a bump up with red. And then maybe people who are medium, they might be a little bit more like looking for people and might be generally more attracted to people. And so they might be a little bit higher in general than the low people on attraction. And again, we have to draw it like this. This is the medium people. And, they might get a bump up also in terms of the red color. So far, when we're looking at this, there might be a main effect for low versus medium, but I don't think so. I think the bars are pretty close here, so I don't think there's a main effect yet. And there seems to be a main effect for red here because there's a bump up for those two groups. But let's go to the high. And let's say the high people are going to be a little bit higher in attraction than the other people. I probably should have chose this as the blank one because it's a bigger bar. And then we have over here, and they might just be a bit higher than the other people. But, green is not really pushing their line very high. But let's say this happens. So remember that for low and medium, there was a step up for red, but it was just kind of a step up. Let's just say that our hypothesis is right, that red is something that people who think about sex a lot are really sensitive to. And let's say they have this big jump here because they're really, really sensitive to red. They have this big jump here. And again, this is all shaded in because this is the key for the high. And so here I would say that we probably don't have, well, I'm guessing there probably isn't a main effect for color. I'm sorry, for sociosexuality, because they're so close here, and they're so close here. They're a little bit more different here, but I don't know if this thing would override the other two. It just looks a little bit too close to me. There might be a main effect, but it would be probably pretty small. Is there a main effect for red? Well, we've already discussed that. There was kind of a step up for everybody, a step up for low, a step up for medium, and a huge step up for high. So there's probably a main effect here for red. But then our question again is there an interaction? We could phrase it as simply, does somebody's sensitivity to the color red depend on their level of sociosexuality? And it looks like it does. So again, for the low and the medium people, there was a step up. It kind of goes up a little bit here. For the medium, it goes up, a little bit. For the low, there's a step up there. But for the high in sociosexuality, there's this huge jump. So if we thought about it as lines, we can see that the lines are quite different. There's a small gradient going up. There's a small line going up here. So red is having an impact on the low and medium, but the impact on the people who think about sex a lot, people who are high in sociosexuality, it's huge. There's this big jump here. This is what's called an interaction. So red has an impact, but it has a much greater impact for those people who are high in social sexuality. That's an interaction. It's the old sort of it depends. Does red have an impact on people's attraction? We would say, well, it depends based on these data. If you are low and medium on social sexuality, it has a little bit of an impact. You go up a bit. But if you're high on social sexuality, it's going to have a big impact on your ratings of attraction of other people. So this again is called interaction. And this is why we do these two-factor studies, these two-factor designs, factorial they're called, because we want to see whether these variables interact with each other and tell us a little bit more complex picture. So red having an impact on people's attraction, that's kind of a simple statement. It's a much more interesting statement to say, well, maybe for most people it has a minor impact, but for people who are thinking about sex a lot, it has a major impact on their attraction. So this is again why we do these types of studies. It's actually a lot more complex and more interesting to think about these things. So that's basically what a two-factor ANOVA is that you again would test for the effect of the color. And I think in the example we just had, red would have a main effect. And then we would test a main effect for the other variable, which is social sexuality. And there would be maybe a main effect. It's a little bit uncertain to me because in our data that we just had, again, that the green and blue was not much different. It was a kind of a small difference. I don't know if the red one would have pushed it up. I'm not sure. And then we test for the interaction. So does the impact of one variable on the DV depend on the level of the other one? And our data that we just looked at, we would say yes. Red does have an impact, but that impact is greater for people who are high in social sexuality. So that's a great example of interaction. And all this stuff is just exactly what we just talked about. So don't worry about that stuff. You can look at it. I'm going to post this PowerPoint online, but some of that stuff is just, they make it too complex sounding for what it really is. And so basically, this is the key here for an interaction, is whether there's non-parallel lines. So if you remember in that little thing that I just drew, when I went from, I'm tempted just to draw it real quickly. I'm not going to draw everything again, but I'm just going to draw what I'm going to talk about here. And again, this is a pain in the butt to have to go through all of this stuff right away. So snip and sketch. So when I say lines, it's, let's see if I can do another one. There we go, that's good. So if you remember when I drew those lines, I was comparing, so there's low. So there's like, I hope I did this right again. So I think there's blue, and then we had green, and then we had red. I'm just drawing this real quickly. And then we had low, and the low kind of was like the same between these two groups. And then red had a little bit of an increase. And then the medium had kind of the same thing. They were just a little bit above the low. And then they had kind of the same type of an increase because of the red color. And then we had the high sociosexuality people. And then they kind of showed a similar thing here, but then they had a huge jump up here. So this was high sociosexuality, this was medium, and this was low. And so when we're saying non-parallel lines, we're saying right here. And so actually here it looks like they might be parallel, and that would not be an interaction. But here we can see that there's a huge difference here. You can see it growing. You know, by the end we actually connect the dots, connect the data lines. There's a huge difference, and here there's not much of a difference. There's not much of a difference. So this sort of increasing non-parallel line right here suggests to us that there's an interaction going on. Again, the interaction that's going on is that, again, you can sort of see that there's no main effect probably for social sexuality because everybody's pretty close here. It's only in this one group that they go up. And then there's probably a main effect for red because red has higher scores. So even with the medium and low, the scores went up. And then there's an interaction, and the interaction is indicated with here, with this thing that I just squared, a non-parallel line that, you know, when we're comparing those three, high, medium, low on social sexuality, there's a little bit of a difference here for green and blue. But boy, the high sociosexuality people see that red, and the buzzers are going off in their head, and the attraction goes way up. And so that's the interaction. That's what they mean by non-parallel lines. If we would have connected those dots, because we had little bars, we had a histogram, we sort of connected those boxes, the top of the boxes, it would look like a non-parallel line. Oops. And that's how they express this interaction. They just say A by B. So we would say color by social sexuality. And if you ever see SPSS output, that's how it expresses it. Typically expresses it one variable times another variable. That just is expressing the interaction mathematically in SPSS output. So here's another example. So I think I'm gonna snip this just because I want to draw on this. Even though some of this might be pretty straightforward, but I think for some people they would like this kind of drawn out. And I'm going to expand this too. And so you can see here, there's a study. We don't even have to know much about the study. We can kind of see what's going on here. And so what this study is, it's a study of people doing an oral presentation. And I think they're essentially given a script that they have to memorize, and then they have to perform it. And the dependent variable is how many mistakes do you make? So how many mistakes do you make? That's the dependent variable. And then there's one IV and one PV. And by the way, these are different findings, so just consider these things separate. And so the IV is that you make the person present to nobody. You might record it with a video. And so you record the video so you can actually count how many mistakes they make, but there's nobody there except for the video camera or a smartphone or something like that. The other one, you give them an audience. Depending on how mean you are as an experimenter, you could have 3 people, or you could have 30 people, or 300 people. If you're really mean, make somebody really nervous. Probably with these data, I'd say maybe around probably 10 to 30. So that's an IV. And then there's a PV, which is self-esteem. And they dichotomize it here. So they have low self-esteem and then high self-esteem. And so if we look at these data, for one, we can ask about the main effects. So the main effect, is there a main effect for audience? I'd say so. We just look at the lines here. I'm being careful not to draw here. If we ignore self-esteem, so just ignore self-esteem, just look at these lines. This line goes up, you make more mistakes. If you have high self-esteem, you're making more mistakes with the audience versus no audience. And if you're low self-esteem, you're doing the same. You're making more mistakes with an audience versus no audience. So this line goes up. If we sort of average this, the line goes up. So audience is causing more errors. So having an audience, you make more errors, and so there looks like to be a main effect here. So I'd say that there's a main effect, and the data suggests that the main effect is that having an audience, you make more mistakes versus no audience. Then we can also test for the main effect for self-esteem. And so if we look at this, so it also seems to have a main effect, because at both points, the low self-esteem people make more mistakes, right? They're up here. They're making more errors. So there looks like there's a main effect for self-esteem, and it's in the direction of if you have low self-esteem, you're going to make more errors than if you have high self-esteem. So here we have main effects, two main effects. And we can ask, well, do we have an interaction? And it's fairly easy to answer because we have lines here. We can ask, are the lines parallel or not parallel? Well, here the lines are parallel. The distance between these lines, to me, it looks like it's the same. It's the same slope. The slope of the line here looks like it's the same as the slope of the line here. It looks like it's equal. So there's no difference in the slope. The lines are parallel, so it looks like we have no interaction with these data. Okay, let's say we ran the experiment and we actually got these data. So it's the same study. It's the same study, so errors is a dependent variable. And we have audience versus no audience as the IV, and then we have people's self-esteem as a PV, low and high. So the main effects might be a little more difficult here, but let's look at that. So is there a main effect for audience and no audience? If we take the average of these two and the average of these two, I'm guessing there's probably no main effect, because it would be about here to about here. And I'm guessing there's no main effect for this one. No me. And then we can ask about esteem. And so we have low and high. So the average here would be about here, and the average here would be about here also. I'm guessing probably washes out. There might be one if you have a large sample size, but I'm fairly sure it's no main effect. Then we can ask about interactions. Is the line parallel? No, it's not. The slope of the line is different. This slope is different than this slope. So there's probably an interaction. And the big thing that I want you to get out of this lecture is not only identifying whether there's an interaction based on a graph, we won't be computing anything, but on a graph, identifying an interaction, we can see it's not parallel line, and they don't have to cross. So you can see that these lines don't cross. It's just whether they're parallel or not. And so now we have to interpret it. Well, let's look at the data. So one way to frame it would be just to look at high self-esteem. Or I'm sorry, at self-esteem. So people with different self-esteem levels, do they react differently to audience versus no audience? So let's look at high self-esteem. So high self-esteem is right here. I don't want to draw on this because I don't want to make it too mucky. But it looks like people who are high in self-esteem, they don't change in terms of the number of errors, whether there's no audience there or an audience there. So for them, the audience, no audience IV has no impact. For the low self-esteem people, it seems to make a big difference. For low self-esteem people, they make this about 6 errors, and if there's an audience there, they're making around 10. So that would be one interpretation. You could say the interaction is such that people who are high in self-esteem are not affected by the audience, no audience variable. However, people who are low in self-esteem make many more errors in the audience condition versus the no audience condition. So while that seems a bit wordy, just keep it simple. So keep something to compare. So I would take like one of the lines. This is an easy way of doing it and say, well, what happens with this line? Well, for this line, which is the highest self-esteem, there's no change. It's 4 to 4. And then this line, the low self-esteem people fall apart and they make a lot more errors with the audience there versus no audience. Just say that. Just keep it simple. Say those simple sentences. It's a wordier thing than we've been doing, but it's still a simple sentence. You could also flip it. So there's always different ways you can interpret it. So you can interpret around the audience. And I'm looking at this. It's a little bit harder. So if you liked what I just did, I would fast forward over the next 30 seconds or so. But if you want to hear about the other way, you could take it from the audience. So we're taking from the self-esteem before, but you say there's an interaction. And you could say that the interaction is such that in the no audience condition, and here I'm going to start writing, in the no audience condition, the difference between low self-esteem people and high self-esteem people was relatively small. However, with an audience present, low self-esteem people made substantially more errors than high self-esteem people. So it's a little bit more wordy, and I think you have to think a little bit more about it than interpreting the lines, but you can also say that. You don't need to say both, because each of those things is essentially saying the same thing. It's just taking different perspectives. So if you want to say in the no audience, there's not much of a difference for self-esteem, but in the audience condition, the difference between low self-esteem and high self-esteem gets really large. You can do that if you want to. So again, that's an interaction. So a non-parallel line, and the effect on the DV depends on these two variables working together. Audience, no audience, and self-esteem work together to produce these results. And again, the major thing I want you to get out of this lecture is being able to look at these things. And, you might do a quick interpretation of the main effects. And again, sometimes like that one, you're not 100% sure. You can say it's kind of, but the big thing is to know how to interpret the data in terms of the interaction and state it in words. So we've already talked about this. So we do a main effect. So in that case, we looked at the main effect for audience in terms of the errors made. So that's the DV. We would do a main effect for esteem, self-esteem. Does self-esteem affect the number of errors made? That's the main effect. Then the interaction. The interaction is, does audience, no audience play with or interact with the self-esteem to produce the effect on the dependent variable? And so each of these has an F-test. And again, we are not going to do this by hand. So there is no homework, and I'm fairly sure there's no SPSS because I just gave you some, I'm going to give you some exercise at the end of this lecture, which essentially is the same type of learning that you would do there. But I'm not going to promise 100%. I'm 90% sure that we don't have one, don't have an SPSS lab. So you would have a similar thing here. You would have three Fs, and you can see the summary table is a little, looks more complex, but it's not too bad. So there's always this between and within we're going to do. And then there's three Fs. You can see there's an F here, there's an F here, and there's an F here. So let's say that this doesn't necessarily match our numbers, but let's just say that experiment that we just looked at, the first variable, factor A, could be the audience, no audience condition. So you'd have the sum of squares, degrees of freedom for that, and the mean squares, and you'd create an F. And by the way, the F comes from this factor's sum of squares divided by the mean squares. So there's the mean squares here. And then the F comes from taking 40 divided by 10, because that's within. So 40 divided by 10, it's 4. You don't need to do this. So if you're scratching your head and saying, I'm tired, I don't know what this means, don't worry about this. I'm just explaining it to people that want, but I'm not going to test you on this. So let's say that this factor is the self-esteem. So you have the sum of squares for that, at degrees of freedom that, you get mean squares from taking the sum of squares divided by the degrees of freedom, just like we've been doing before. So you have a mean squares here for the self-esteem. And then what you would do is you would take 60 divided by 10, and you get an F of 6. So every single one of these mean squares for this factor, and the interaction, you just divide it by the within. And then you have the interaction. So does audience, no audience interact with the self-esteem to affect the mean number of errors? So you have sum of squares for that. You'd have a degrees of freedom for that. Then you have a mean squares. 100 divided by 1 is 100. Then you would test the F by taking this mean squares, divide it by the mean squares for the within. 100 divided by 10 is 10. And so definitely there is a pretty substantial interaction here. Again, you don't need to produce this table. I'm just explaining it and showing you what it looks like. In case you see an SPSS output or you see a table like this. In the future, I'm not going to give this to you on an exam. This you can skip. I'm not going to make you hand calculate these things. All I have this up here for is to let you know in the future, if you go into statistics as part of your career, and if you do, I'll guarantee you that you will be making $20 to $50 to $80,000 more a year than you would do otherwise, just having that skill. You know that you can find these formulas. So there are formulas for effect sizes. Actually, I disagree with this last thing right here. So basically, again, we want to look at interpreting the results. So I don't think that you need extensive practice. I think with our color example, attraction, color, and social sexuality, that kind of made sense. It was pretty easy. And then also for this study, I think you were able to see that. I would say it doesn't take extensive practice. It'd be nice to get a little bit more practice, and so we can interpret these results, and we will do this at the end of the lecture. I'm going to give you one more before I give you some exercises. And I might do the first one in the exercises, we'll see. And so I'm going to snip this, because I like to draw on things. And I'll make this as tight as I can so I can expand it. Okay. So even if I have no idea what the study is, I can find out pretty quickly. Um, so we have the test score. So the DV is some sort of test score. So it looks like they had to read something, a text, something that was written. Um, and it looks like that they had an IV of two different conditions, two different levels, and probably between subjects, I'm guessing, but it could be within, but I'm guessing it's between. So you have people reading the text on paper and people reading it on the computer screen. So that's our IV to see if mode of presentation affects the test score. And then time seems to be the other IV. So there's two IVs here. So in one condition, you say that there's a fixed time. So you say you have 10 minutes to do this. You have 10 minutes to do this task and to take the test. And in this one, it's self-regulated. So you give the person the text. You say, well, go ahead and read this. And whenever you want, take this test, and the test is on time. So that's what self-regulated means. There's no time limits. So let's look at this. So this gets a bit more complex, perhaps, in terms of main effects. Let's see if there's a main effect for mode of presentation. So papers over here, computers over here. So average of that. Probably not a main effect, I'm guessing. Just by looking at that, there's no main effect. And again, all I'm doing is looking at papers over here. And if we looked at fixed times versus self-regulated, the average would be right here between these two dots. And then computer screen, the average would be about right here. So we're looking at this difference. Probably not a big difference. And so I'd say that there's no main effect. And then let's look at time. So fixed time, the average is about right here. Self-regulated is about right here. There might be a small main effect, I'm guessing. And it kind of looks like where they are in this picture. It looks like there might be a main effect for fixed time is leading to higher scores. Well, you might say, why is that? Well, maybe people focus better if you give them a time limit versus if they just are self-regulated. Maybe it's going both ways. Maybe people are just daydreaming and not really concentrating in the self-regulated, or maybe they're thinking that, oh, this is probably pretty easy, so I'll just read this in a couple things. Whereas if you give a fixed time, you know that, oh, this should take me this long to do it, and your behavior is a little bit more guided because you know exactly how difficult this thing is, how complex the test might be based on how much time you're given. So there might be some cues there going on also about what to do. You don't have to do this type of stuff. I'm just sort of talking about the substance of this. So is there an interaction? So remember, to ask if there's an interaction, we ask whether the lines are parallel or not. So definitely the lines are not parallel. In fact, they cross. Again, you don't have to cross the lines to have an interaction, but definitely if you have a cross line, it's definitely an interaction, but just look for if there's different slopes of the lines. They're not parallel. So what's the interaction like? So just looking at this, and I might interpret this two different ways, and I won't draw the first way because I think this one's really easy. This one's standing out to me this way. So if we look at paper, there's not much of a difference, right? If we look at paper, it doesn't really matter whether you're self-regulated or fixed time, you're doing about the same, roughly. You're very close. However, if you're on a computer screen, the fixed time is much better than self-regulated. So I'd say that the interaction is such that the difference between fixed time and self-regulated is very small when the mode of presentation is paper. However, when the mode of presentation is computer screen, fixed time led to better performance versus self-regulated time. So again, that might sound wordy, but I'm just saying what I see here. So the interaction is that for paper, the difference between fixed time and self-regulated is small. They're about equal. However, on the computer screen, the fixed time people did much better than the self-regulated time people. So I hope with that statement, you can see that I'm not doing some sort of weird interpretation. I'm just looking at the dots in this case and describing them using these labels that are here. Let me flip that, which is actually looking at the lines. So for people doing the fixed time, I would say that they did slightly better under the computer screen condition versus the paper. However, for the self-regulated people, they did substantially worse in the computer screen mode versus the paper. So you can just state it like that, and just simply we're saying that for the fixed time people, it doesn't seem to matter that much. There's a slight advantage to the computer screen versus paper. For the self-regulated people, there was a great advantage to having paper versus the computer screen. Or you could flip it. You can say for self-regulated people, the computer screen was a huge disadvantage compared to the paper. So again, I hope with that example, you are not, you are seeing, I should say, you are seeing that you're not doing this super complex thing. You're just describing the stuff. So in one method, I just described the dots. How far are the dots away? Well, they're not far away from here. Well, not far away for the paper. So fixed time self-regulated doesn't make much of a difference for paper. However, the dots are really far here. So for people doing a computer screen, they did much, much better under fixed versus self-regulated time. And then for the other, so you only have to do one or the other. So the other approach is just looking at the lines. So look for the fixed time people. Well, they did a bit better in the computer versus paper. Not huge, but a bit better. But boy, look at this. For the self-regulated time people, they did really bad in the computer screen versus the paper. Their line goes way down. So again, it's not too complex. It's just taking each part and interpreting it. So just like with anything with statistics, I believe, and maybe life too, instead of staring at this and say, oh my God, there's so much there, you just say, okay, how can I take this bit by bit? Well, the bit by bit is either looking at the dots and how far they're away, or look at the lines and see how they change. And that's all you need to do, as long as you just sort of put in words what's going on, what you see. In football, sometimes they say, believe what you see. So if you see a line going down, you see the dots are big or close together, well, believe what you see. Just talk about it. Don't have to think too much about it. Just talk about it, simply. So you don't need to memorize this. This won't be on the exam, but when you write up the stuff, of course, what you're doing is you have two main effects and you have an interaction. So when you write up your results, and you'll be doing this perhaps in your Psych A class if you're a Psych major, your methods class, is you would write up results for the main effect. So let's say main effect of color. So was there a main effect? Report the F. If it was significant, well, which color was seen as more attractive? Then you would do the same thing, probably a separate little paragraph. You'd do a main effect for sociosexuality. Did sociosexuality have an impact? So you'd have your sentence reporting that, reporting your F, and then if your F is significant, you would have some sort of sentence about your post-hocs about which groups differed. And then you would have a small little paragraph for the interaction. So was there an interaction between color and sociosexuality in terms of affecting attraction? Give the F information, the stats, the inferential statistics information, just like we normally do. And then you will also do a post-hocs, which I'm not going to make you do here because we're kind of doing it visually. And so if there's an interaction, you typically what you do is you usually would like to graph it, just like the graphs we've been looking at, and then see, well, exactly what does the graph look like, and how can we describe that graph? And you'd state it in a sentence like we've been stating already. So just like our other ANOVAs, the two-factor ANOVAs has assumptions. So that first assumption down here, that the observations are independent from each other, that's just basically saying that the way we did the study and the way that nature is in some ways, I guess, is that those variables are not impacting each other. For example, we're not having too many highly sociosexual people in the red group versus the green and blue group. So that would be, they're not independent in that case because we have too many people in one group and they're maybe tilting the scale a little bit towards the red color overall as a main effect. And we don't want that. And then there's this thing about normal distribution. So there's with all of our stats that we're looking at, except for chi-square, which is I think literally our last stat we're going to talk about in this course, is they are what we call parametric statistics, which assumes normal distributions of the variable. And it's not the sample data that we have that's normally distributed. It's the assumption is about the population. And there's tests for this, but we aren't going to do it because they're pretty complex, and we want to keep it simple and straightforward in this class. And then we have this homogeneity of variance. And so when we're looking at our different variables, red, green, blue, those groups should have roughly equal variances in terms of how they differ on attraction. And if we're doing high, low, medium social sexuality, those groups also should be roughly equal in their variances in the attraction ratings. And so that homogeneity of variance is a very common assumption. Because what happens is if our variances differ a lot, our estimates are not accurate. And so we make these assumptions that they're equal variance, and SPSS does test them. Okay, let's get to the big part of the lecture, which is the examples, or which are the examples. And so I'm going to post in Canvas, and I want to double check that I've actually posted it. Not everything's up quite yet. I have to still put the videos up and things like that. That's weird. Yeah, here it is. And just going to do this. And sorry about this. I should have had this canvas loaded earlier, but I thought I was going to save it from dying on me by doing that. And so right there. So I'm going to post this video right above here. And then you have the PowerPoint if you want to use the PowerPoint for studying, taking notes. And then right here, if you click this, you're going to open up a document for interaction examples. So this is not graded. This is not homework, but I want you just to practice. So it says graph the following data and interpret the interaction. So I don't ask about the main effect here. So it's the interaction. So there's 4 examples here. I'm going to do the first one. So basically it's the DV is the mean annual salary. And then we have 2 PVs. So we have men versus women. So I'm dichotomizing gender, even though I don't think that's the nature of gender, but we'll just use that for this easy example. And then we have professional, non-professional. So people in professional careers and people in non-professional careers. And so what we do is we're going to graph this, and I'm going to actually snip something I can draw. And so follow this example. So I'm actually going to graph it. We were given the graphs right away, but I'm going to ask you to graph these things. And so there's always two ways that you can graph these things. For sure, always your dependent variable is going to be, again, I have to draw this little mouse pad, always here. So here is the salary. So how much does somebody make? That's the DV. And then we have men versus women and professional, non-professional. So one of the things have to go down here, and the other thing has to be lines. So here I'm going to put, actually, I'm going to do it both ways. So I'm going to put non-professional and professional, whoops. And then I'm going to make lines for men and women. And so all you do is just graph the information. And so here, for the non-professional, men make 43, women make 41. And so you probably want to put little lines on here and labels, but we'll just, this 40's around here, let's say. So again, for non-professional, men make 43, women make 41. So we have a 41, and we have a 43. I just put my two little dots there. And then for professional, men make 95, women make 75. So if we go up here, women are making 75 around here, and men are making 95 around here. And we just connected that. So these were women. There's 41 to 75. And that's women. And then for men, connecting these dots is about like that. This is very rough. And so you're asked to interpret the interaction. So go ahead and do that. Pause, and I'll talk about it after you pause. Again, the big thing is there a non-parallel line? This is not parallel. So this is actually only a difference of 2,000. It might have been even closer down here. And definitely, even with my little sort of quick little sketch, you can see that the lines are not parallel. The difference here is pretty small, and the difference gets bigger over here. It's 2,000 here, it's 20,000 here. So there's an interaction. And so the interaction you put in words. Again, there's two ways you can talk about it. You can talk about the dots. Let's talk about the dots first. So looking at the dots, is there much of a difference in the non-professional careers? No. So there's an interaction. The gender differences in salary are small, very small in non-professional careers. However, the gender differences are much larger in professional careers, such that men make more than women. Or you can interpret the lines. So for women, there is a small increase in salary from non-professional to professional. However, for men, there is a larger increase in salary from non-professional to professional. Sorry about that, it expanded on its own. So you can interpret that. You could also draw it the other way if you want to. I'll draw it the other way. And sometimes there are better ways to draw it. So you only have to draw it one way. Either way that you draw it, it should show the interaction. So I'll draw it the other way with gender identity on the bottom. Oops, that's not the snippet I want. I want the blank page. I want the blank page, so let's snip the blank page. And we'll just draw it's the same data, it's just we're going to have the lines be different. We're going to have the lines be the professional, non-professional. So again, this is the money, this is the DV, and we're going to put gender here. So we're going to put male, female, and we're going to have professional, non-professional as the lines. So let's do men first. So we have 95 and 43. So we have 95, which would be way up here, and we have 43, which is down here somewhere, roughly speaking. And then we have women. And we have women 41 and 75. So 41's about here, and 75 is about here somewhere, roughly speaking. And so the line here is, and actually should be going down slightly. There's a $2,000 difference here. Should be going down slightly. And again, this is not non-professional careers. And then this line is for professional careers. So either way, either the one I just showed you or this way, it's fine. Either way, you can do it. So is this an interaction? Well, yes, it is. We can see that the difference between here is smaller than the difference between here. So they're non-parallel lines, so there's an interaction. So how would we describe that interaction? Again, we could describe the dots, or we could describe the lines. So let's describe the dots. So for men, there is a big difference between professional and non-professional careers in terms of salary, with professional being a lot higher paid. For women, while there is a difference between non-professional and professional careers, the increase in salary for professional careers is substantially less than that for men. So I've just explained the dots, or you could explain the lines. For people in non-professional careers, gender does not seem to make much of an impact on salary. However, for people in professional careers, women make substantially less than men do. Period. So that is an interpretation of the interaction. So you see you have choices. You could graph it in two different ways, and once you've graphed it, you can interpret the interaction by talking about the dots, or you could talk about the lines. Either way is fine. And so there are 3 more examples that I want you to work through. If you want to work through them one at a time, you can, because what I'm going to do is I'm going to go over these examples myself now. And actually what I'll do is I'll explain the studies real quickly here. So here's always the DV. So here is the average ratings of likability, and we're asking people's peers. And we're looking at 2 predictor variables. Again, we're dichotomizing gender, which is not the reality, but we're just doing it for ease of interaction interpretation. Men versus women. And then we have narcissist versus non-narcissist. And then in this study, the DV is the mean amount of support given by the partner. And then we have an IV and a PV. So the IV is a stressful situation versus not stressful. So we bring people in the lab and we just have a relaxing situation and we watch the couple together versus we have a non-stressful situation, or sorry, stressful situation. We stress out the partners and see how they interact with each other. And of course, we give them some sort of task they have to do or something they have to do and see if they support each other. So one situation, it's very relaxing. The other situation, it's high stress. And then we have a predictor variable. We're having, and this is the partner who's giving support. We have people who are secure, who are the quote-unquote partners that we kind of all want, I hope, which are the basically the supportive partners. I should not say supportive because you look at the data, but people who are very balanced in their relationships. They give give to you and they can ask from you help. And so they're very balanced. They have a good sense of themselves, but they're also able to get into a relationship and be a partner, be a part of the couple. And so they're very balanced in that way too. They don't lose themselves in relationships like an anxious person, but they're also not standoffish like the dismissive person, and they think they're better than the other person. So they're what we call interdependent. So you have a good sense of yourself, strong sense of yourself, but you can also be in a relationship with somebody else and be a couple. They also can express your feelings well. They can read your feelings well. They can respond to you according to your feelings, etc. Then we have avoidant or dismissing people here. This maybe I've been calling it dismissing in class. So these are people who think they're better than their partner, who are standoffish, who are pretty cold emotionally, generally speaking. They're closed off emotionally, they're defensive, that type of stuff. And then the final one, we have a study with an IV and a PV, and we're looking to see if people will help strangers in need, in the sense if they need money for something. And so our IV is the stranger. So we actually have people, and this stuff that studies usually happen in the real world. So the person doesn't know they're in the experiment, but it's typically in a nice sort of way, in the sense that it's like everyday behavior. I shouldn't say nice, but it's everyday behavior. You can't do something extreme. You can't create a weird extreme situation, but maybe a stranger who needs money for a parking meter. That's what they do a lot in these types of studies. Although I don't think it's a parking. Well, it could be LA parking meter. The $6 to $7 is for sure what you might be paying, even for an hour in downtown LA. And so typically, what you do is you have the stranger and you have the same person. So the looks don't matter. How the person interacts, you have them highly trained to be the same, and they follow a script, so they say the same words to everybody. But you have this person, they either dress up in sort of ratty clothes, so they look poor, versus they're dressed up in like a three-piece suit, so they look like they're rich. And so this is an IV. We manipulate this. And we were basically waiting for strangers to walk down the street, and we asked them for change for the parking meter. And the only difference is the same person is either dressed in ratty clothes and they look poor, quote unquote. I'm poor. I came from a poor family too, so don't don't criticize me for this. But the markers of being poor. So the person would look at them and think, "Oh, this person's a poor person." And then rich people, like a three-piece suit. And then, even though they don't consent to the study right away, we did this without their knowledge. We're going to grab them because we want to find out if they're rich or poor themselves. And so we do the study and we see if they give, and then we grab them and say, "Oh yeah, you were part of this study, and this is what the study is kind of looking at. Can we ask you some?" Well, we don't say that right away. We want to ask them the questions before we tell them what's the study about. But we give them some demographic questions, and they might include something like gender and gender identity and your occupation and how much money do you make, this type of stuff. Get some sort of marker of whether they're rich or poor. And we measure that. And that's a predictor variable. So it's just something about the person. So the DV is how much money did they give to the person? And the IV was that person asking for that favor, did they look rich or poor? And the PV was the person giving the money rich or poor? And what I'll say is all of these data here are based on real studies or numerous real studies, and the direction of these data are in the direction of the real studies. So let's go ahead and do it. So go ahead and do those things. I'm going to go through the solution for all three of these. So you can pause and watch 2 if you want before going to 3. It's really up to you. So pause, do these exercises. When you unpause it, I'm going to go through the answers. Okay, I'm assuming you've unpaused. If you haven't, pause it. And then I'm going to go through each one. So this is number 2. And I'm going to get my thing to draw on. And I'm going to do number 2. And I don't want my Outlook. Oof, that's dangerous. So the first one is the DV of likability, whether you're male or female in a dichotomy world of gender, which I don't believe in, but we have it here anyway, and whether you're narcissistic or not. So how do people see you in terms of how likable you are? So likability is the DV. So likability. So do people like you? You can put likability, I just don't have space here. And we have non-narcissists, so people who are not narcissistic, and we have narcissists. And the other thing is males and females, but I'm going to just take this one at a time. So non-narcissists, men are 6.8 in terms of likability, and women are 8.4. So men were about 6.8, and women were about 8.4. Again, you can scale these. And then, so I want to sort of mark myself so I don't forget. This is men, this is women. Typically you would label on the right, but I'm labeling it there so I don't forget. And then we have narcissists, men 8.6, women 6.3. So men is 8.6, which is a little bit around here. So again, that's men. And women were, I think, 6.3, but let me check. Yep, narcissist women, 6.3. So that's down here somewhere. Again, that's women. We can draw it properly. So we want to connect the lines. Women's dot with women's dot, and the men's dot with the men's dot. Okay, this should be pretty easy, right? Is there an interaction? Yes, there is. Not only are they not parallel, but they're crossing severely. And again, these data are in the direction of research that's out there. So when we interpret an interaction, we can interpret the dots or we can interpret the lines. So I'm going to interpret the lines first because then I can draw the dots. I kind of like that. So there is an interaction. For men, narcissists were seen as more likable than non-narcissists. For women, the opposite happened. Narcissists were seen as less likable versus non-narcissists. Period. You can flip it, you can state it in different words, but as long as those things are there, that for women, narcissism, non-narcissists were seen as more likable than narcissists. You say that also. It means the same thing. And then we can, or the other thing is we can interpret the dots. There is an interaction such that for non-narcissists, women were seen as more likable than men. However, for narcissists, men were seen as more likable versus women. Period. So that's how you interpret it. And again, the information I'm giving you here is based on previous research, and you can kind of interpret this. Let's just sort of talk about the content a little bit rather than just stats. So here, you know, probably has a lot to do with gender roles. So men are supposed to be kind of, I shouldn't say jerkish, but men are supposed to be assertive and at least slightly arrogant about themselves. The arrogance is seen as confidence, self-assuredness, etc. So gender roles is playing a thing here. So for men, the narcissist traits are like hyper masculine gender roles in our culture. And for women, if they act self-confident, then they are bees. There's a word there, I won't say it. They're bees, or they're emasculators, or they're violating essentially their gender roles and challenging the power of men. So men and women too, who believe in traditional roles, will be very negative about women who are showing these assertive traits, and vice versa. If a man is showing themselves to be less self-confident, they're going to be seen as less likable because it violates gender roles. However, the gender roles for females in our culture, I'd say even now still, but definitely traditionally, is that women are supposed to be more mild and meek and followers rather than leaders, etc. So the interpretation of these data are the gender roles. So basically, the data look like that. Let me do it the other way. So I had gender on the bottom. No, I had narcissism on the bottom. So let me just do gender on the bottom real quickly. So you can compare graphs, but you should have a crossover there too. Let me just do it quickly. It takes more time to get the snippet going, and I can't get a quick access to it, I don't think. So let's look at the study. Making slightly different decisions. Sorry about that little, maybe I'll erase that. Oh, that's a ruler I don't like. Oh, erase the whole thing. That's okay. Start over. That's the thing of having this little mouse pad. Probably don't want that big, but again, this is how likable somebody is. And then we have the gender here. So we have male and we have female. And then the narcissism is going to be the one. So if we have the narcissist line, men are going to be up here, 8 point something, and women are going to be somewhere around here, 6 something. So this is the narcissism line. And then for non-narcissists, men are down here somewhere, and women are around here somewhere. And again, it's a pretty obvious interaction because the lines cross. It's not just they're not parallel, they cross. And you can do the same sort of interpretation. So for non-narcissists, women were seen as more likable than men. And for narcissists, the opposite happened. Men were seen as more likable than women, period. We can interpret dots. For men, being narcissistic led to higher ratings of likability versus non-narcissistic. However, for women, the opposite occurred. Non-narcissists were rated as more likable than narcissists. Okay, let's do the next one. So if you haven't done 3 yet, please pause and do 3. And so here we go. I'm actually going to pause this real quickly. Okay, this should be recording now. And let's do the next one. So number 3. I don't have the snippet, so let me snip it. So let's see here. So let me snip this so I have something to draw on. And there it is. I have to remind myself what 3 is. So here was that study where we're putting a couple in a lab situation and they have to do something together, and we give them either a stressful situation or a stressful situation or a not stressful situation, and we see how much support they give to each other in this task that they're trying to do together. And we're also seeing whether that partner who is secure versus avoidant influences their level of support. So let's go ahead and snip this. So I'm going to, so this is the support giving. And then on the bottom, I'm going to have the stressfulness of the situation. So not stressful, and then stressful. And then I'm going to draw the different lines for the different attachment types. So here we have avoidant. So actually, I'll just do it this way because I was doing dots earlier. So maybe I'll just do that. So non-stressful, we have avoidant is 7 and secure is 5, roughly. So 7 and 5. And then in the stressful situation, the avoidant is 2.3 and secure is 7.9. So 2.3, actually it was around here, and then 7.9 about here, roughly. So this was the avoidant people. This is also the avoidant people. Remember, go ahead and look at the data if you want to remind yourself. And then this is the secure people. So is there an interaction? Well, this one's pretty easy too, right? The lines cross, definitely there is. So what is the interaction? So again, we got two ways to do it. We can do the lines or we can do the dots. And so if we do the lines, there's an interaction such that for secure people, they gave more support under conditions of high stress or stress versus no stress. However, for avoidant people, they gave less support under conditions of high stress versus low stress. Or we can interpret the dots. So under no stress conditions, avoidant partners gave more support than secure. However, under stressful situations, secure people gave substantially more support than avoidant people. So either one of those interpretations is fine. It's saying the same thing. It's just which perspective are you taking? And I'll draw the different perspective here too, with attachment B on the bottom. In case you did that, you can compare your notes. And so here we go. And let me get the data up here so it's easier. So it's gonna be, again, oops, sorry about that. Support giving is the thing. And we're gonna have avoidant attachment and secure attachment. So those are on the bottom. Then we're gonna do the stress being on top. And maybe I'll just draw the line. So there's different ways of doing it. Maybe drawing the lines is easier. So let's do the non-stressful. So avoidance 7.8 and 5.2 for the secure. So this is non-stressful. So it's around 7, 8, and around 5. So again, that's the stressful situation. Non-stressful, oh, I'm sorry, that's the non-stressful. There we go. Non-stressful situation. And then in the stressful situation, we have 2.3 and 7.9. So 2.3 around here, and 7.9 is around here. So in the stressful situation, it looks like this. So again, there's two ways we can interpret these. It looks similar, right? We have lines crossing. So we can interpret the lines. So there was an interaction. So in the stressful situation, secure partners gave more support than avoidant partners. However, in a non-stressful situation, avoidant partners gave more support than secure partners. And we can also do the dots. So there's an interaction. So for avoidant people, they gave substantially more support in the non-stressful situation versus the stressful situation, while secure people gave more support in the stressful situation versus the non-stressful situation. So that's the statistical interpretation. And then in terms of what's going on and again, this is actually based on a real study. And essentially what this says is we've sort of been talking about this in class is you can't tell what somebody's like until you see them under stress, or more significantly, you under stress. And there's other research that substantiate this, like first dates. On first dates, avoidant people can look really, really nice because they're not really stressed out about the date because they don't really care whether there's a relationship or not. They don't really care about relationships, and so they can look really good. They're over here. They're up high, and then people interpret that as them being a good person. However, you need them, and then they disappear. They're busy. They can't help you. So that's the concept: is you can't tell somebody what somebody's like until you're under stress. And actually, the data are kind of like this. I might have maybe exaggerated this difference, perhaps, but dismissing people are overly supportive in this non-stressful situation. They don't need to. There's not much support needed. You're not under stress, and they might be, oh, are you okay? Are you fine? Da, da, da. Because it's low stakes, right? They can seem like they're really supportive, but it's low stakes. And so, and then the secure people are just like, "Are you okay?" And you say, "Sure, okay." And if you look okay, then they're not going to press it. Whereas the dismissing people or the avoidant people are going to, "Oh, give me a hug. Is everything fine?" They're gonna overdo it. Okay, now we're in the last one. Okay, so we have the study where we have an IV. We have the same person, but they're dressed nicely or not so nicely. So strangers are walking by and infer that the person has money or doesn't have money. And the person, that stranger's asking for money, sometimes it's something like that's very reasonable everyday thing, like for money for a parking meter. Could be anything else, but let's say money for the parking meter. And then there is the giver who's walking on the street. They don't know they're part of the study, and then we find out later whether they have money or not. Are they rich or poor? So how much money does a person give? Is there an interaction between whether somebody looks like they're rich or poor and whether the person is a rich giver or a poor giver? So let's go ahead and snip this and draw this. Okay, so I'm ready to go. Let's bring up the data here. So we have money. How much money does a person give the stranger? And let's do the, so remember the stranger is, oops, I actually want the poor stranger to be here. Sorry about that. So let's have the poor stranger. That's our we call it confederate, somebody working with us. Against the same person, just dressed differently. So how good they look and things like that don't matter in terms of their face and things like that. And then we have the rich giver and poor giver. And so let's look at the rich giver. So the poor stranger gets 150 on average, and the rich stranger gets 675. So 150, I think it was 675. I'm going to put roughly here. This is the rich giver, correct? Yep. And then the poor giver, they give $7.50 to the poor stranger and $7.25 to the rich. I want to make sure where that rich person is. Okay, $7.50 for poor and $7.25 rich. I want to connect these lines before I forget. I think it was something like this and something like this. They don't cross. And this is the poor giver, rated PG. So is there an interaction here? Well, I hope you say yes, because they're not parallel lines. Even though they don't cross, they're definitely not parallel. And so again, we have two strategies to interpret. We can interpret the lines, or we can interpret the dots. Let's do the lines first. So for poor givers, it didn't matter much if you were a poor stranger or a rich stranger. Just like 25 cents was the difference, I think. So it didn't matter much for the poor giver. For rich givers, they gave substantially more to rich strangers versus poor strangers. Or we can interpret the dots. And so for rich strangers, it didn't matter much whether you were a rich giver or a poor giver. There was some difference, but it wasn't huge. There was a much bigger difference between givers if you were a poor stranger, in that poor givers gave substantially more than rich givers. And so before you turn off this video, I want to say that this, like the other data that we have in our interactions here, are based on real studies. These aren't the real data per se. Some of this might be a bit exaggerated, but the trend of the findings is exactly this. I think there's a big lab in UC Berkeley that studies this, and other places have studied it too. Basically, and it demonstrates probably something that you may be aware of, that poor people are much more charitable than rich people, even though they have a lot less money. And so you might know that, and this has been substantiated in real life experiments like this. Let's do the other way. So we're going to have the givers on the bottom. So just in case you drew that, I'm going to draw it too, so you see it should look similar in some ways. Let me see what it looks like before I say that. But it should also demonstrate an interaction, of course. I did that last time. I need to have my link up, and then I'll highlight this, and then I'll draw on it. And again, the DV is the amount of money people give that stranger. And I think I have the givers down here, right? We have a poor giver and a rich giver. Yep. And so let me get to my data. So let me draw so this is I need my stranger data, and it's right across there. So I'll do the poor stranger. So the rich giver is 150 and poor giver is 750. So this is 750 and this is 150. And that's for the poor stranger. And then for the rich stranger, we have 675 and 725. So a 725 here and 675, was it? Yep, 675. So something like this. My line is going a little bit in a weird way. So it looks probably roughly like this if you drew it this way. And so it looks like somebody's got big legs here and flying, and they're looking at their little hands with a box or something. Anyway, it must be getting late, making weird jokes. And so here we go. And so this is the rich stranger before I get sidetracked. So we can interpret the lines or we can interpret the dots. So if we interpret the lines, For poor strangers, poor givers gave substantially more than rich givers. However, for rich strangers, that difference was smaller, even though the poor givers still give more. Or we can interpret the dots. So if you're a poor giver, there was not a lot of difference in how much you gave between a rich stranger and a poor stranger. However, if you were a rich giver, you gave substantially more money to a rich stranger versus a poor stranger. And so that's our last example. And so obviously, as you can see from the amount of time that we've taken in this lecture, that the big thing, do look at the study guide, but the big thing that I want you to take from this is this whole stuff about interaction and interpreting the interaction. So interpreting these things in words. And so we've gone over a number of examples about how to draw data and how to interpret those drawings, those graphs, in terms of what the interaction is. And so make sure that you can do this. And again, you can ask me questions during live sessions. And I'll talk to you later.